Next up, we got nutrient pollution. And this really is an excess of nitrogen and phosphorus in a water. Both of those will cause an increase of enrichment, which means initially more plants, which then as they die, more decomposers do well. More decomposers, there's less oxygen, so a higher biological oxygen demand. And that overall reduces oxygen levels, which then can cause a fish kill. What is this whole process called? Well, when you have enrichment causing the oxygen, dissolved oxygen to decrease, it's called eutrophication. And eutrophication happens in many different places, but one big example is called the dead zone, which we'll look at in class a little bit more. And that is in the Gulf of Mexico where hypoxia occurs. What do you think hypoxia means? It means the reduction of dissolved oxygen. So you have reduced oxygen, therefore who's not going to do well in that area? Yeah, fish. So you're going to have reduced fish and other organisms that require oxygen. So that's why it's called the dead zone, because really nothing lives there because there's too much nitrogen and phosphorus in that area. And where do you think those nitrogen and phosphorus come from? So if I have my Gulf of Mexico here, here's Florida, and there we go. Louisiana comes out here. Why do you think I have so much of that nutrients here? Well, what river's right here? Yeah, the Mississippi. And a lot of agriculture takes place on the Mississippi. So you get a lot of runoff going into here and a lot of nutrient pollution that occurs in that Gulf of Mexico because of the runoff of the Mississippi. If we look at some different sources of nitrogen across the world, you have agriculture in different forms, septic, land development, wastewater, automobiles, and then agricultural deposition or atmospheric deposition. So there we go, we've got nutrient pollution. Other type of pollutant is organic compounds. And what does it mean for something to be organic? It means contains carbon. Some examples are like pesticides, solvents, industrial chemicals, and plastics. Like examples like I have benzene down here, dioxin here, and PCB. And dioxin's really nasty stuff. That can enter the environment through incinerators. It can also through vehicles, different types of manufacturing processes, and volcanoes. And then PCBs, which are polychlorinated biphenyls, are endocrine disruptors. And these can cause huge problem in food chains and a lot of birth defects and offsprings of different things, different organisms. Some preventions to reduce the amount of organic compounds, use less toxic products. So if you see a product, you're getting some type of cleaning product, and it says non-toxic, that would help. And remediation, so it's already in there, how are we going to clean it up? Tertiary water treatment is one where you add more chemicals to clean up the chemicals, which we'll talk about more when we get into sewage treatment. Inorganic compounds, what do you think inorganic means? Yeah, it just doesn't contain carbon. Examples are like salts and heavy metals. Origins can be industries, mines, runoff, and oil drilling. Lead is a big one, and mercury is another big one. So we've got our two really large ones there. And lead is still found within paints and soil. And a buildup of lead in adults can cause hypertension or high blood pressure. In children, it can cause mental disorders. And then also in pregnant women, premature deliveries. Mercury, the main source of mercury getting into the environment, is through power plants. 33%, hint, hint, wink, wink. And then waste incinerators, which is a place just to burn trash, and then medical incinerators as well. And as it's released from power plants, it accumulates in food chains, and then it gets into humans mainly by eating What do they tell you not to eat too much of? Yeah, fish. I had a friend tell me once about, we were eating sushi, and I was like, man, I love sushi. And I was like, what is the problem? Fish is so healthy for you, I could eat this forever. And he basically said the one thing that could happen by eating too much sushi is you could have an accumulation of mercury that could cause problems. And different types of problems that occur from mercury, you can have mental retardation, cerebral palsy, and developmental delays in children. So if we look at the cycle of mercury here, main source is by power plants, and as that settles down, because mercury is somewhat dense, denser than air, settles down and eventually runs off into low-lying areas into water. And then there, it gets into the algae that then are consumed by different invertebrates, then are consumed by fish, and then are consumed by humans. So that's how it can accumulate within humans. And then lead poisoning, symptoms, you can have headaches, you can have abdominal pain, can cause anemia. In children, sources, lead-based paints, they can chew on, kids chew on basically everything. So if their toys have lead-based paints, like there was a problem a couple of years ago with this, they can get exposed there. You can also have paint, like paint on the walls that flakes off and then gets in the air, and kids chew on everything, and that's another way. And also soils. So when kids are outside playing, they get dirt everywhere, they could get it in their mouth. So that's another place of where lead can get into children. Radioactive substances. We talked about this in Chapter 11, and the sources of these can be nuclear weapons, nuclear power plants, medical and research facilities. This can pollute the air, water, and soil. An example would be like radon. Thermal pollution. What do you think thermal pollution deals with? Yeah, heat. So where do you think thermal pollution is the biggest problem? Of course in water, but where and what would cause the thermal pollution? Well, think of how we generate electricity. How do we generate electricity? Yeah, we use different types of heat transfer. And eventually, some of that water that is heated up is discharged back into waterways. So with that warmer water, it could alter food webs, it can decrease fish populations, and dissolved oxygen doesn't hold well in water, or oxygen doesn't dissolve well in water if it's colder.